so to wrap up this unit on probability, we're going to talk about some applications as well as certain types of probability that we really, we have talked about in the other lessons. So there's three types of probability. Theoretical probability, and I've talked about this before, is what should happen, okay? That if you roll a single die 6 times, a 3 should come up once. That's what should happen, because there's a 1 in 6 chance of a 3, okay? But if you actually went and rolled it 6 times, would you get a 3 once? Not necessarily. You might not get it at all. You might get it a couple of times. That's experimental probability, okay? So selective judgment, it is a type of probability, but it's not based on any math. You would say, oh, you know what? The probability of getting a 3 when I roll a single die is 100% because I like the number 3. Okay? It's just based on some judgment. So knowing that, like I said, theoretical probability is what should happen. So let's look at these situations and tell me, is it theoretical or is it not? So Jake thinks the probability of winning on Tim Hortons Roll Up the Rim contest is 100% because he has always won. Is that what should happen, or is that what Jake thinks? What he thinks. So it's not theoretical. Okay? Samantha knows that there's 52 cards in a deck. She also knows that half of them are red. So she states the probability of drawing a red card is 1 out of 2. Is that theoretical? Yeah, that's what should happen. A radio station is giving away prizes to every 5th caller. However, they'll only accept 50 calls. Rachel declares that if she gets through, she'll have a 1 in 5 chance of winning a prize. No?
Is it the wording with that? Because she says declares.
Yeah, or she says.
Well,
there's a prize awarded to every 5th caller, and if she gets through, if she's one of the actual, like a caller is somebody who gets through.
yeah, nice
Okay.
theoretical.
So is it a 1 in 5 chance? Yeah, it is. Because every 5th caller wins a prize. So if she gets through, her chances are 1 in 5.
That like, because there's 50 calls, so there's like.
Yeah, this is kind of meant to throw you a little bit.
No,
What
yeah.
all that means is that there would be, 10 winners?
Yeah, that's what.
10 winners. Okay, but the probability is still 10 out of 50, which is 1 out of 5. So it is theoretical. And finally, Sydney and Ken are studying the weather. Every day they write down the weather conditions. They found that it seems to rain every Tuesday. They then stated there is a higher probability of rain on Tuesday. Not theoretical. Yeah, that's pretty. Okay. Like I said about experimental probability, if you actually do an experiment or do a situation then you record everything that happened and you calculate the probability after that. So going in, and let's say for an example, let's use this for as an example. Okay. That's to jump right in. So a bag has 11 blue marbles, 15 green, and 4 yellow. And Antonio picks marbles out of the bag. After he picks a marble, he records its color, places the marble back in the bag. After picking 30 marbles, this is what he got. Okay. Well, how many marbles are in the bag at all times? 30, right? There's 11 blue, 15 green, 4 yellow that add up to 30. Okay. So I'm actually going to jump to B first. Okay. According to, before he actually did the experiment, what would be the probability of drawing a blue or a green? Here's the marbles. There's a total of 30. What's the probability that he draws a blue or a green? 19? Blue or green?
Oh, blue or green? 15. Whoa, no. Those two numbers get together.
What two numbers?
Oh, the green and the blue.
What are the numbers? Which is?
26.
Thank you.
I don't know.
Yes, you do. Okay, so what should happen is it should be 26 out of 30. Okay. Remember, what should happen? Before the experiment. But now, what's the actual probability when she did it? What's the probability that she draws a blue or green when she did it?
27.
Sorry? 27. Because blue or green is 9, 18. So it should have been 26, but when she actually did it, it was 27. Okay? What's going on here? So experimental actually drew marbles. And it makes sense that she got something very close to what should have happened, but it's going to be a little different because it's what should happen and what actually happens will not match up all the time. They should be close to each other. Especially like if she did this several times over. Like if she drew 30, 30, 30, and she did it like a million times and you averaged all those out, she'd probably be really close to 26. Okay? But she only did it one time, so she was one off what should have been. So I know I'm doing this, and I should reverse these orders because I like doing theoretical first. What's the theoretical that she drawing a yellow? 4 out of 30. But when she actually did it, right. Okay. So make sure you understand the difference between the two. So again, theoretically, what should happen? Experimental, what actually happens? And now, just a little bit more on selected judgment. Like I talked about at the beginning, it's based upon like personal experience or even feelings or biases. Okay? So people can actually make up probabilities. Maybe it matches, maybe it doesn't. Usually it doesn't. Okay? Because like I said, there's really no logical basis of what they're saying. Okay? And that's going to obviously be the least accurate. So here's a situation where three people make claims. I want you to tell me which one represents theoretical, which one represents experimental, and which one represents just a judgment call. So they're all talking, these three, Sierra, Blake, and Savannah, are talking about the lottery. And in this lottery, they guarantee that a $10 million prize will be paid. Sierra argues that someone has to win the lottery, so why couldn't she be the winner? Blake says, well, there are many people buying tickets for the lottery, therefore the chances of winning are actually low, very low. Savannah agrees with Blake that they shouldn't buy lottery tickets. However, she's basing her reasoning on the fact that her parents have been buying lottery tickets for years and never won anything. What type of probability is Sierra using? Someone has to win the lottery.
No. I don't know, because like, it's just like a cat, it's somebody's fault.
Yeah, it's like, she's not really basing it on any math, is she?
Yeah,
She's just saying, well, somebody has to win it.
just like,
Yeah. So she could be subjective. How about Blake? Chances of winning are very low. He didn't say specifically,
yeah.
but is that what should happen? Like somebody has to win the prize, right? So the chances of that happening, somebody winning, is 1 in however many people bought it, which is very low. So that would be considered. That's what should happen. Even though he hasn't attached an actual probability to it. And how about Savannah?
Experimental.
Yeah, experimental would be, well, my parents experimented with it, and this is what happened to them. You could also make the argument for subjective. Okay? Because she's basing it on, like, well, this is what happened to my parents. And so there could be, we'll say experimental. But like I said, you could make an argument for subjective. Okay. One last example, talking about these three probabilities. Elijah needs to get from one city to the other, one side of the city to the other. He knows that Portage Avenue is the most direct route. However, he also knows that the perimeter highway has a higher speed limit. How might Elijah use the following types of probability? You know what? No, I don't like this question. No, I think it's more confusing than helpful.
I don't like it.
I figured you wouldn't. So let's just leave that one. I don't. There's a better way to do it. Okay, so finally, just to wrap up, some applications of probability. Medicine. Okay, so experimental probability is often used in medical research. Person can't calculate the theoretical probability of the benefits or side effects of some new medication, so they base it on experiments. Okay? And in order for the experimental probability to be useful or valid, the size of people you use has to be large enough. Okay? So if you just said, if you experimented on, let's say you have a new medication that, I don't know, eliminates or reduces migraines, okay? And you decide to, okay, well, I'm going to take two subjects, going to take two people, and I'm going to give them that suffer from migraines, okay? And I'm going to give them just regular medication for 2 weeks. And then I'm going to give them this new drug I'm hoping for the next 2 weeks. And I'm going to see the results, okay? So let's say in one of the results, the new migraine medication helps one. And therefore this researcher says, well, guess what? My new migraine medication helps 50% of the people that take it.
How many people are listening to?
2.
Okay.
Right? That's a very small sample. That's a little hard, you know, like there's a lot of questions about that. Because it could have easily been 0 had 2 people, or it could have easily been 100%, which is why you need more people. Like if you had 50 people and it helped 25, then you have a better case to say it helps 50% of people who take it. Okay? That's what it means by sample size. Okay. So let's look at an application of probability in medicine. So a researcher has found a medicine she thinks might be a cure for the latest flu. This researcher then gives the medicine to 50 mice who have been infected with this flu. Of the 50, 30 are cured, 13 are showing improvement, 7 showing no improvement. What's the probability that the mice with the flu, well, they all have the flu, will experience at least some improvement?
86%.
And how did you get that?
Because
Yeah. 30 plus 13 out of the 50 had either were cured or had some improvement. So yes, 46 out of 50, or sorry, 43 out of 50, which you correctly said is 86%. What's the probability the mice with flu will show no improvement? 14?
I just.
Yeah, you're right.
Oh,
Yeah. I mean, you could do it this way, say, well, 7 out of the 50 and make that into percent. Or, like you said, if 86% show some improvement, the remainder of the 100% must show no improvement. So you could have just done 100 minus 86. Yeah. And what type of probability is being used here? Experimental, because an experiment. Okay. This is a good lead into our next unit because we're going to talk about everything associated with buying and maintaining a vehicle in the next unit. So vehicle insurance. Well, part of the costs you pay to insure a vehicle
depends on how valuable your car is to theft. Right? So they keep records of, when cars are stolen, what kind of car, what year, things like that. And, well, it could, yeah, yeah. The big thing though is the make, is the timing. Okay, that's sort of the big thing. If it's an old beater, yeah, probably not. Okay, which generally means it has a lot of kilometers. So anyway, so certain vehicles, after they record all these results for years and years and years, they keep recording them every year. Certain vehicles are more prone to being stolen. Okay, they're more popular vehicles to steal. So for example, Manitoba Public Insurance, that's where you get your vehicle insurance from, the company. It's a company of the government. Stated that of the 210 Pontiac Firebirds insured, 30 were stolen last year. Okay? So based on this data, if you own a Firebird, what's the probability your vehicle will get stolen? Yeah. 30 out of 210. Remember, we don't have to reverse these. And therefore, what's the probability it will not be stolen? Not flip, that's odds. 180. Which is actually what I was going to do. What are the odds in favor of being stolen?
What? 180.
The odds of being stolen, in favor of being stolen. You're on the right track. We don't use 210. We only use the total in probability.
30.
We use the numerators in odds. 30 to 180. Yes, that's right. And then the odds of it against being stolen will be 180 to 30. How might this probability affect the insurance costs that you pay for your Firebird? Could cost more. Because that's a fairly high probability of being stolen. And which type of probability was used? Is it what should happen or what they collected, so it's experimental. Okay. All right.